Hey guys, Mr. Fernando here, and here I am showing simplifying square roots or simplifying radicals. We're going to be using a method called factoring. There's a couple of ways that you guys can actually do this, but I'm going to be showing the factor tree way. So we're talking about square roots, right? So let's think to ourselves, what is a square root? Well, over here on the left side, I'm going to start off with some examples of what we call perfect squares or perfect square roots. These are ones where we don't got to do anything fancy, and we just got to know the rule of what is a square root. So a square root is this right here, and it's kind of like the opposite of a exponent. So an exponent would be something like this, right? 4 to the power, okay, I don't know why it's being covered. 4 to the power of 2. 4 to the power of 2, right, is 16. It is saying 4 times 4. So a square root is like kind of doing that backwards idea, where we're trying to think to ourselves, what two numbers that are the exact same when multiplied equal 16? So the square root of 16 is 4, because 4 times 4 is 16. So for 25, right, what two numbers multiplied against 25 that are the same? Well, it's 5. So the square root of 25 is 5. 5 times 5 is 25. 8 times 8 is 64. And then finally, 7 times 7 is 49. So these are perfect squares. They have an exact number that you can multiply that without decimals to make the square root. So in class we learned about, okay, what if we're given a number where there isn't? So there is no number that you can multiply by itself. So you can't do 6 times 6 because that equals 36. You can't do 5 times 5 because that's 25. So it's kind of in between those two, right? So this is what we're gonna do. We're gonna split it up using a method called the factor tree method. So to do this, right, what I'm essentially doing is trying to find secret square roots inside of this number by splitting it up. So same idea, finding two numbers. I want to find two numbers that multiply to make 32. So in this case, I'm gonna do the numbers 8 and 4. 8 times 4 equals 32, right? So this is not like a perfect square, like I know they're different. But I'm gonna keep splitting up these numbers until I can't split them anymore or they become prime numbers. So in this case, I can split up 4 and it is 2 times 2. And then I can split up this number and it'd be 4 times 2. And then this one can be still split up and it'd be 2 times 2. So what I have here, right, I cannot split up these anymore. I've reached the very end of my factoring. Because the only way you'd split up 2 is going 2 times 1, which we're not doing that. We're going all the way, so they're prime numbers now. And this is the idea. If I took all of these numbers, right? If you did 2 times 2 times 2 times 2 times 2, that would equal 32. So what we've basically done is we've gone, the square root of 2 times 2 times 2 times 2. How many do I have? 1, 2, 3, 4, 5. So we have one more. What we've essentially done is just kind of like changed our mind of what we're actually doing, right? 32, this is 32. Just to really split it up. Now, here's where the trick comes, right? Can't do the square root of 2, but what I can do is the square root of 2 times 2, which is 4. Square root of 4 is 2. And then I have another pair right here. 2 times 2 would be 4. Square root of 4 is 2. But then I have one left over still inside this house. So this has to stay, unfortunately, in the house because it doesn't have a buddy. And from here, what I have found is that the square root of 32, if you break it apart, becomes 2 times 2 on the outside, which is 4. And I still have a root 2 on the inside. So that's how we simplify a square root. You take out all the perfect squares that you can from the number. You're breaking it apart and finding the square roots. So without doing this, I'm gonna show it again just a little more sped up. So I'm gonna do this number right here. I'm gonna make a factor tree, and then I'm just gonna show you kind of like the quick way of doing it, right? So what two numbers when multiplied equals 50? Well, 5 times 10. I can't split up the number 5, so it has to stay there. I can split up 10 by going 5 times 2. Okay, can no longer split these up. Alrighty, and I'm gonna write this is like a template for my answer. What I am looking for is pairs. I see right here, whoop, there's a pair of 5s in my factor tree. So I know I'm gonna take a 5 out of my answer. This too, because all lonesome and has no friends, it doesn't have a buddy, has to stay inside the house. So, has to stay in answer. 5 root 2. I was able to find the square root of 5 times 5 or 25. And there you go. So from here, I'm gonna try doing this one, right? Now this one's a little different because I have a variable now as well inside of here. So I'm gonna end up splitting this up a little bit. You don't need to, but I personally am. So in this case, right, I'm gonna be finding the square root of 75 and the square root of x2 separately. I'm gonna do those separately. And I'm gonna write this for my template answer, just so I have it, so I know this is gonna be my final answer down here. So I'm gonna do the number first. So again, let's split it up. What two numbers equal 75? There's quite a few, but let's do 25 and 3, okay? Can't split up the number 3 anymore, so I'm gonna keep it right there. And then right here I have 5 times 5. And I can no longer split this up. So, what do I have? Well, I have a pair of buddies right here. Right here. Pair means that this is gonna end up going on the outside. So 5 on the outside. Then I have a 3 still left over. So that 3 has to stay inside the house because it doesn't have a buddy that we're able to find the square root of. So 5 root 3. Are we done? Not quite. I still have that x to the power of 2. And so if I had to split this up, right, what makes up x to the power of 2? That would be x times x. And oh my God, look, they have buddies. A pair of buddies means that they get to leave the party, they get to go outside. So they got to meet the 5 out here, and so it would be 5x times root 3. So 5x times root 3 would be your final answer for this, simplified. Okay, let's do it one more time, or a couple more times. Again, there's already a 3 waiting on the outside on this one. So this one's waiting to multiply with anything that we take out. So, oopsies. Let's see, woo! I don't know what just happened there. Let's split up the number 28. So I'm gonna do 14 times 2. Can't split up the number 2 anymore. Then I can split up this by going 7 times 2. And I can see where I have a pair, right? I have a pair of 2s right here. And so for my final answer, I'm gonna put the 2 on the outside, because again, I have a pair of 2s, so I was able to take one out. The 7 doesn't have a buddy, so it stays inside the house. And this 3 that was originally there is meeting up with what we took out. So 3 times 2 is 6 root 7 times root 7. Alrighty, last one, truly last one. So this one, there's a 25 on the outside just waiting, and I'm finding for the square root of x to the power 5. So as a reminder, this would end up being x times x times x times x times x. 5 x's, right? I have 5 x's. So let's see if this is my final answer. 25 is on the outside. Let's see what kind of pairs I was able to grab. Pair, so that's 1x going on the outside. Pair right here, that's another x that was able to go on the outside. And then this was all left all by itself. So final answer ends up being, on the outside I have 25 times x to the power of 2, because x times x is to the power of 2, times root x. That's your final answer. That's simplified. That is simplifying square roots.